Now we're going to look at another comparison test. We've looked at the direct comparison test. Now we're going to take a gander at the limit comparison test. And to start with, we'll make a couple of assumptions. We've got these positive term series here. We've got this one involving a sub n, this one involving b sub n. And like I say, a sub n, all the terms are positive, and same is true for b sub n. Now, what we want to do is consider this limit, the limit as n goes to infinity of a sub n over b sub n. We want to think about that limit. Now, I'm going to start off with what I call case 1. Let's suppose that that limit is actually equal to some finite positive number. Okay, now I say finite. It's not infinity and it's not 0. Let's say it's bigger than 0. So it's bigger than 0, less than infinity. What intuitively, what does that mean about a sub n and b sub n? So let's just think about this. Now, this is not a proof. I'm not trying to prove the direct comparison test. The proof is pretty straightforward and easy, but I just want us to kind of intuitively understand what's going on here. If this happens, if that equals some positive finite number, it kind of means, if you think about it, that a sub n is not dominating b sub n too much, and b sub n is not really dominating a sub n. It's kind of like these are kind of partners working toward this limit. Okay, so the bottom is not dominating the top, top's not dominating the bottom. They're kind of working together for this, working toward this number. And it seems that that would imply that they either both converge or they both diverge. So let's put that down. They both converge or both diverge. Now, so just intuitively, that seems to be the case here. And you can, the more you think about it, the more you see, yeah, that I can see how that would be true. And you can play around with examples. And like I say, you can look at the proof of it too. But anyway, that's case 1. Now, let's take a look at case 2. Let's suppose that this limit of a sub n over b sub n is equal to 0. It's equal to 0. Now, that seems to indicate to me that b sub n is dominating. Okay? Because the bottom is growing faster. It's getting bigger, so much so that the top can't keep up and it's just going to 0. So it seems to me that that would mean the bottom is dominating the top. In other words, b sub n is bigger than the top, bigger than a sub n. So that seems to say this: if b sub n, if that one converges, then a sub n converges. Seems to indicate that to me, right? Because it looks like b sub n is just exploding. It's getting bigger and bigger and bigger, and a sub n can't keep up. So b sub n is, if it's converging, then a sub n must be converging. Okay? So there's a couple of cases. Now, case 1 is really what we're going to use most of the time. This case 2 and case 3 are kind of like special cases, but I just like to look at them all together. Okay, now let's look at case 3. Let's suppose the limit as n goes to infinity of a sub n over b sub n is equal to infinity. Well, that to me says that a sub n is dominating b sub n. Okay? It's dominating b sub n. So what does that mean? Think about it. If B sub n converges, or think about this, if B sub n diverges, what does that mean about A sub n? That's bigger than B sub n. If B sub n diverges, then A sub n diverges. Okay? So these are the three cases. And this is the limit comparison test. The limit comparison test. For the most part, we're going to see this A sub n over B sub n equals L. Either both converge or both diverge. But then you have the kind of these special cases down here of case 2 and case 3. Okay, so let's see how this works. Let's look at an example here. Let's suppose that we've got this series, 1 over 2n plus 1. N goes from, let's say, 1 to infinity. And I want to use the limit comparison test to determine if that converges or diverges. Now, here's the thing. You might say, well, you've only got one series there. So what we have here is we're given A sub n. And what I need to do is I need to find another series, a B sub n, that I can use to evaluate this. In other words, that I can use to implement the limit comparison test. I've not got a B sub n there. I just need to find a series that I know converges or I know it diverges, and then I can do this limit. Well, how am I going to do that? Well, here's a trick. To find this B sub n, you're going to have a fraction. Take the dominant thing up top. In this case, it's 1, right? Just the dominant term up top, and put it over the dominant term of the bottom, but leave off the coefficient. So I'm going to put it in. In other words, I'm being kind of sloppy, but it's okay. I just need any old B sub n. So I just take the dominant thing up top, put it over the dominant thing on the bottom, which is n, and I left off the 2n. That's my B sub n. Now, here's the thing we know about B sub n. B sub n diverges. And we can show that with the integral test. But one of the things about this particular series here, this is the harmonic series. This is the harmonic series, and it diverges. And anytime we see that series, we can just say, okay, this diverges because of a harmonic series. Now, you could also use this P series thing with P equals 1. You can use the integral test, but this right here is the harmonic series. And harmonic series diverges. So we can do the limit comparison test and use this harmonic series. So let's see how this works. We've got the limit as n goes to infinity of 1 over 2n plus 1 divided by, instead of dividing by, let me just multiply by the reciprocal. Be quicker. See, I'm just multiplying by the reciprocal of b sub n. Now, let's take a minute and dig what we have here. We have the limit as n goes to infinity of n over 2n plus 1. Well, we know how to evaluate that. It's like finding the horizontal asymptote. This is 1/2. That limit is 1/2. The ratio of the leading coefficient, since the degree on the top and the bottom are the same, we learned that in like pre-calculus. So that's the limit. It's 1/2. This is finite, bigger than 0. Now, here's the deal. Since this one diverges, and by, I'll say, harmonic series, since that one diverges, this one diverges by limit comparison test. And there, we've done it. We've we've accomplished what we were supposed to do, because what we were supposed to do is determine if that converges or diverges. And that's what we did there. Now let's look at another one. Let's suppose that we've got, let's say the square root of n over n squared plus 1. Okay. And what I want to do is come up with the b sub n. Okay. So here I go. B sub n, I'm going to take n to the 1/2. That's what's up top. And on the bottom, I've got n squared. Okay. So there's my b sub n. Just being very sloppy. Now, this is n to the 1/2 minus 4/2, which is n to the negative 3/2, or 1 over n to the 3/2. That's my b sub n. See, from here to here, I just used, law of exponents, subtracted the exponent on the bottom. Okay. Now, let's look at our limit. We're going to take the limit as n goes to infinity of, here we go, the square root of n over n squared plus 1 times the reciprocal, right? The reciprocal. There, like that. Now, let's see what's going to happen here. We've got the limit as n goes to infinity. N to the 3/2 times n to the 1/2 is going to be n squared. That's n to the 4/2 over n squared plus 1. Now you can see that limit is 1, which is finite. Okay. Now, the question is, what does this tell us? Well, think about this series here. This right here was our b sub n. Now notice this series right here converges. Okay. That series converges. This converges by p series, with p is equal to 3/2, which is bigger than 1. So remember, when you recognize that as a convergent p series. Therefore, this series converges by LCT. Yeah, limit comparison test. Okay, so there we have it. Now, as far as finding this b sub n, I want to finish off here just by talking about looking at some various series and looking at, well, how would you choose the b sub n? Let's suppose we've got this one. What would the b sub n be? Well, the top, just put 1, and then the bottom, an n squared. See, I just look for the dominant thing on the bottom. Let's suppose that we've got 1 over the square root of 5n plus 1. Well, b sub n is 1 over the square root of n. Okay, just being very sloppy with it. Now you could make it 1 over the square root of 5n if you want, but maybe that would make it unnecessarily complicated. So we've got n squared minus 20. Let's try this one. Okay, and we're looking for a b sub n. Well, I'm going to take the top, put the dominant thing up top, which is n squared. On the bottom, I'll put the dominant thing, okay, which is n to the 5th, okay, the dominant term. There. So it looks like we can use 1 over n cubed to do our comparison.